New products are proven to be the driving force behind change and renewal at the corporate level. A study over 89% of manufacturing companies globally view new products as the leading driver of future growth. It is, however, the most complex, financially taxing, and multifunctional process within the organization, requiring the coordination of individuals from sales to marketing to quality assurance. The new business environment today consists of high growth and innovating industries where organizations have to develop capabilities that allow them to be very flexible and agile, and at the same time be able to incorporate new product and process technologies that enable them to develop and exploit better practices. Companies are also outsourcing tactical design activities, enabling 24/7 dynamic models, allowing its engineers to focus on core activities, thus reducing development times by aligning their value chain to achieve optimum flexibility and performance. In the concurrent engineering, there are tools for the development and innovation of new products. In this case, we will talk about the QFD tool.
What is this? An objective view of what users are looking for in the product and the requirement they must have. A prioritization of which characteristics are the most priority to add and which are not necessary. A situation of who our current product is facing to competitions and what are the aspects to improve to be more competitive. Quality matrix. Age translations use a matrix called House of Quality, HOQ, for identifying customer needs and establishing priorities of engineering characteristics or design requirements to satisfy the customer needs. The quality matrix has some steps which are 1. Customer needs 2. Product characteristics 3. Process characteristics 4. Characteristics of the sub-process.
New modification of the QFD. In order to remove complication in product development aimed at the reducing time to the market and decreasing development cost. Product development teams have modified QFD to deliver the right benefit and the right cost. Some of the changes to traditional QFD are just in time QFD, Turbo QFD, QFD Optimizer, and Fuzzy Trimmed in QFD. Application of tools for better result include a comprehensive framework using multi-objective decision modeling (MODM) approach for extending the hierarchic process to quality development. The synthesis of decision tools is used for designing product requirements and for assessment of impact of decisions. Integrative model. This model seeks to develop a product based on qualitative by means of qualification of lower level criterion together with those of higher level, and this way obtain a winning product. Customer collection process. The process begins with the systematic collection of customer needs. Gather formal and informal means of the customer contact in Gemba through focus group by conduction market survey and through questionnaire.
Process identification of characteristics engineering. The engineering characteristics are based on the textual information that is gathered from the questionnaires in done or interviews. Per which comparison of CN using agent vendor method is done as a part of multi-tribute decisions to determine importance weight of CN. Relationship rating between CN and AC is developed using or strong, medium, weak, or no relationship method of eliciting contributions of AC to the satisfaction of CN. Per which comparison of AC is done to find the interdependence and interrelations keep, and integrated the conventional HOQ with the modified HOQ should be normalized to generate more meaningful representation of AC. This is the equation that is used for normalization.
Introduction of the development of the bike. Based on the information obtained with customers, distributors, and others, the criteria that can be quantitative or qualitative, such as power, useful life, comfort, acceleration, etc., are chosen. After even identified, they are grouped according to the affinity they have with each other. One way of grouping the attributes is by means of the first, secondary, and tertiary classification. To determine the engineering characteristics, meetings were held with two engineers who were experts in the design of motorcycles, taking into account the information provided by customers and the brainstorming. The engineering characteristics should cover all the important aspects for the client. The characteristics originated in the case process are engine characteristics, fuel delivery system, electrical and fuel ignition, power transmission and control, frame dimensions, cross-section, weight and payload, ground clearance, service and maintenance, and warranty. A short computational procedure to get an E-vector is to raise pairwise comparison matrix to powers that are successfully squared each time. The process of squaring stops when there is no significant change between all the elements of the pairwise comparison matrix in two successive steps of squaring. After that, the row sums are calculated and normalized to get an E-vector. The consistency ratio is evaluated to check for inconsistency of judgments, such that the value of ratio exceeding 0.1 are indicative to the need to revise judgments of comparison matrices.
Matrix for the comparison by pairs of the secondary attributes of the client. Using the normalized matrix as mentioned above, the priorities of the customer attributes can be obtained. The percentage relative importance of each of the 6 secondary attributes. Relative importance of tertiary attributes. After obtaining the relative priorities of the higher level attributes, the relative priorities of the tertiary level attributes are found out. The lower level criteria are weighted with respect to the higher level priorities, using weighted pairwise comparisons matrix for the secondary criteria.
Weight relate to secondary and tertiary attributes. Finally, the relate priority of secondary and tertiary attributes and the overall priority study are established. The result obtained from wherein the lower level criteria WRT, higher level criteria and overall priority.
Correlation and interdependence. The 9 areas of AC identified were scored based in the direct impact of CN in the HOQ between CN and NC, employing a traditional 9-3-1-0 scoring method. 9 indicate high impact, 3 indicated medium impact, 1 indicate small impact, and 0 indicate no impact. Matrix for correlation between CA. The strength of reinforcement between AC is evaluated. The interaction between a pair of AC is a fractional value between B sine 1. Using the relation rating scale of 1, 0, 3, 9. A parallel set of interaction score is defined. The approach developing an interaction matrix consisted with the concept of correlation. The matrix assumed that the interaction of AC is mutually equivalent.
Integrated relationship matrix. The element of the matrix can be described as similarity in the interaction data. The element of the matrix demonstrate the full impact of the CS in the NC, include the direct impact of interaction. The element of describe the full impact of the CNC in the NC.
Results report. According to the previous table, it is analyzed if the impact of the engineering characteristics is consistent with the stated importance of the client needs. In the previous figure, it is shown the weights of customer attributes with and without the engineering characteristics impact. For instance, the criteria power of client needs has an importance of 7%, yet it receives 13% of the engineering characteristics weightage. Similarly, the criteria affected under extremes of the client needs has an importance of 3%, but it receives 9% of the weightage. This indicates a disproportionate allocation of the engineering characteristics and a need to redefine engineering characteristics important to the various customer needs.
Evaluation of the client's need. It provides information of the importance CE for a specific need of the client. An example of this is the impact of the characteristics of the proper functioning of the engine. Importance of the CE for the CN and the general project. The importance of engine characteristics to the CN can be determined using this equation. where WI is weight of the criteria and CIJ is normalized values of the metrics.
Reading conclusions. The influence of design or engineering characteristics and overall commitment can be determined using customer feedback. Companies need to define a customer-centered product strategy that capitalizes ideas and identifies strengths and weaknesses to develop a product using an iterative approach. A perspective is obtained of the importance of the engineering characteristics for the specific needs of the client and for the general objective. General conclusions. QFD is a tool that allows you to invest the client's requirements in technical requirements. QFD is based on continuous improvement of the product development process. QFD is a source of information for future designs and process improvements, improves market success, allows self-evaluation and comparison with competitors.